Dear students, today we start another points from the chapter number 2, partial differentiation. First point that I want to explain here is exact differential. Exact differential. We know that total differentiation diff is given by gamma f by gamma x, that is fx into dx plus gamma f by gamma y into dy. Here, if gamma f by gamma x is again a function of xy, that is m of xy, and gamma f by gamma y is again a function of xy, n of xy. That is, we can write df is equal to m dx plus n dy. M dx plus n dy. And if the condition gamma m by gamma y is equal to gamma n by gamma x is satisfied, then the given function df is an exact differential. This is the definition of exact differential, and if this condition is not satisfied, then the given function is not exact differential. The condition satisfies having exact, neither not exact differential. Definition may be asked for 2 marks, but in general, question may be asked like this. Show that. I take one example to understand this particular concept. If df is equal to 5x square plus 3y dx plus 3x minus 5y square dy, show that the given function df is an exact differential. To show this, we have to show this condition. That means, on comparison, we have m is equal to 5x square plus 3y and n is equal to 3x minus 5y square. Taking partial differentiation of m with respect to y, gamma m by gamma y. Partial differentiation of first term 5x square is 0 because x is constant in this case. Partial differentiation of 3y, that is plus 3. That means final answer is 3. Similarly, gamma n by gamma x is equal to partial differentiation of first term 3x, here x is variable, therefore 3. Second term minus 0. because y is constant in this case. And as we consider del by m by del by del by x, then in this case the condition del by m by del by y is equal to del by m by del by x is satisfied. Therefore, the given function diff is exact differential. Therefore, given function is an exact differential. In the examination, such a question may be asked for the 4 marks, and here definition may be asked for the 2 marks. And after discussing this concept, here we come to another point, that is chain rule. In our mother tongue, it is known as Sakritzanian. What is that chain rule? To understand that concept of chain rule, here we consider one function f is a function of xy. The meaning of this statement is that f depends on x and y. Then again, suppose that x is a function of u and y is a function of u. The meaning of this statement is again that x depends on u, y depends on u. That means f is a function of xy. Again, x and y are the function of u. In this case, if we consider u changes to u plus delta u, x changes to x plus delta x, and y changes to y plus delta y. Obviously, because of that change in these functions, here f also changes to f plus delta y. And here, when we consider f plus delta f plus delta f is given by f of x plus delta x, comma y plus delta y. Again, taking this f on that side, we can write f of x plus delta x, comma y plus delta y is equal to f of delta m is equal to f of x plus delta x, comma y plus delta y. This f on that side minus f of xy. Again, here rearranging the terms, delta f is equal to f of x plus delta x, comma y plus delta y minus f of x, comma y plus delta y. That is minus f of x, comma y plus delta y. This term in our step is not there. We subtract this term. Therefore, we must have to add same term f of x, comma y plus delta y. Then that minus f of xy as it is. That means in our equation, adding and subtracting the same term, that concept is used here. Then taking first two terms and that of last two terms separately. First two terms and last two terms separately, divided by delta u on both sides. Delta f upon delta u is equal to this divided by delta u, these two terms divided by delta u. Again, rearranging the terms, delta f upon delta u is equal to f of x plus delta x comma y plus delta y minus f of x comma y plus delta y divided by, here instead of delta u, y plus delta y common constant, there is a change in x, therefore divided by delta x. In our equation there is no delta x, we divide, therefore we must have to multiply by that same term, dividing by delta u. Plus, in second case also, x constant, y is variable, therefore rearranging the terms, f of x comma y plus delta y minus f of xy divided by, there is change in x, there is change in y, therefore dividing by delta y, there is no delta y, therefore multiplying by delta y divided by delta u as it is. And by using the definition, we can write here delta u upon delta u, taking the limit of each term, limit as delta u tends to 0. Here limit as delta x tends to 0, like this. By taking limit of each term, we can write directly here df by du. The value of this term is df by du. The value of this term, limit as delta x into 0, f of x plus delta x comma y plus delta y minus f of x comma y plus delta y divided by delta x is that delta f by delta x. Values delta f by delta x. Limit as delta u tends to 0, delta x upon delta u is dx by du plus limit of delta y tends to 0 of f of x comma y plus delta y minus f of xy divided by delta y is delta f by delta y, and limit delta u tends to 0 of last term delta y upon delta u is dy by du. Such equation is known as chain rule. df by du is equal to dy by dy x into dx by du plus dy by dy into dy by du. And suppose we consider f is a function of three variables x, y, z. Then using the same concept, we can apply that dy here df by du for three variables is dy by dy x into dx by du plus dy by dy into dy by du plus dy by dy z into dz by du. In this way, we extend only another term. We can find out the particular change in function with respect to u. Such concept known as chain rule in the partial differentiation. And after discussing this particular concept, chain rule in the partial differentiation, the question may be asked define the chain rule, and problem may be asked in the examination. How to discuss that problem, how to solve that problem, that we discuss here by considering one example. If u is equal to x square plus y square, where x is equal to 80 square, y is equal to twice 80, find du by dt using chain rule. chain रूलच्या साहाय्याने फाइंड आउट करा असं त्याच्यात उल्लेख आहे. That means again this is another method, but here we use that method by using the chain rule, and we know that by using chain rule formula is du by dt is equal to delta u by delta x into dx by dt plus delta u by delta y into dy by dt. Putting the values of u, x and that of y in this expression, we have du by dt is equal to delta by delta x of u x square plus y square into d by dt of x is equal to 80 square plus delta by u, that is x square plus y square multiplied by delta y by delta t, that is delta by delta t of twice 80. Taking differentiation of each term, we can find out du by dt. Partial differentiation of x square plus y square with respect to x twice x into d by dt of 80 square, a constant a as it is, t square is the differentiation twice t, plus here with respect to y, that is 2y multiplied by differentiation of twice 80, that is twice a. Again putting the value of x and y and simplify, 2 into 2 4, a as it is, t multiplied by x is equal to 80 square plus 2 into 2 4, a value of y is twice 80. Again simplify, a into a square, t square multiplied by t cube, 4 as it is, 4 a square t raised to cube plus 4 into 2 8, a into a square t. This is the final value of du by dt. Using this concept, we can find out the value of chain, value of that one differentiation using chain rule. याचा अर्थ काय झाला? दुसरी मेथड आहे. दुसरी मेथड काय? डायरेक्टली ह्याच्यात x आणि y च्या किमती टाकून द्यायच्या आणि डायरेक्ट आपण उत्तर फाइंड आउट करू शकतो. पण ती मेथड जर वापरली तर उत्तर जरी बरोबर आलं तर मार्क मात्र तुम्हाला 0 मिळतील, कारण त्यांनी हिंट दिलेली युजिंग चेन रूल. चेन रूलच्या साहाय्याने आपल्याला त्या ठिकाणी याचं उत्तर मिळवायचं आहे. इथे मी थांबतो. पुढच्या लेक्चरला दुसरा पॉईंट आपण एक्सप्लेन करू. थँक्यू.